Hello everyone and welcome to this tutorial, JSON for .NET Developers. We're gonna start this tutorial with an overview of JSON, just to make sure we all speak the same language and understand the basic notions of the JSON format. From there we will move on to the main topic of the tutorial, the implementation of JSON in .NET with the Newtons of JSON library. And finally, we will see some demos, starting with the basic root operations, followed by JSON merge. I find JSON to be an extremely essential topic for web developers. The JSON format is used today for communication between clients and servers, cross-service communication, and storing data in files and databases. Getting this topic down right will definitely make your life easier, and if you still don't take my word for it, have a look at this screenshot from the NuGet gallery. It shows that the Newtons of JSON library, also known as JSON.NET, is by far the most downloaded package to date, with over 56 million downloads in total. So what is JSON? JSON stands for JavaScript Object Notation. It's an open standard which originated in JavaScript. It is basically a text format that can easily be parsed and manipulated in code, and is fairly readable to humans. Have a look at this JSON example. We will be using this example throughout the tutorial. It represents a gamer's profile. The full name of the gamer is Bruce Wayne, as we can see from the first line. His age 35. The city in which he lives is New York. I'm not going to go through all the properties, but we can also see he recently played Gears of War and Rocket League, and he is a paying customer. A few things we can notice right off the bat in our examples are the delimiters of the JSON format, curly brackets, double or single quotes around strings. Double and single quotes have the same meaning in JSON. Colons, commas, and brackets. Another thing I want to point out regarding the limiters is that white spaces does not count as delimiters in JSON, so I could write the same JSON in one long line without spaces or line breaks, not including the spaces within strings of course, and have an equivalent JSON to this one. So after having a basic idea of what we are dealing with, let's break it down and try to set up the rules that define the JSON format. On the left side, we have our gamer's JSON again. On the right, the raw definition of JSON out of the JSON.org website, which holds formal definitions of JSON and some cool charts and links. I strongly recommend having a look at it. So, our first definition at the top right is of JSON object. JSON objects are surrounded by curly brackets. That is, they start with a left-turning curly bracket and end with a right-turning one. And they contain pairs, also known as properties, separated by commas. A JSON object can contain a number of pairs or be empty with no pairs in it, just empty curly brackets. A JSON pair is a key-value pair separated by colons, where the key is a string annotated with single or double quotes. A JSON array is an array of values separated by commas and surrounded by brackets, just like in most coding languages. And finally, the JSON value. A value can be a string, like the full name of our gamer, Bruce Wayne. It can be a number, and for us as .NET developers, that would mean a double. So it could be a 35, like the age property, or 104.5, like the balance property. The value itself can also be a JSON object, like the address value, and this is the important part here. This object can furthermore contain another JSON object or objects and so on. For example, the street address property could have been made up to an object that could include the street number and name as separated properties. If you'll think about it, this recursive definition of JSON enables us to hierarchically structure any number of objects where the outer object is the parent and the nested JSON objects are the children. What data structure does that remind you? Another value type is the JSON array, like our recently played property, which, like the JSON object, can hold any number of values, including nested arrays and objects. A JSON value can also be a boolean, like the isPaint property. And our last value type is null, indicating an empty value. The null value starts with or without capital letter and written without quotes. Now, before we move on, I would like you to take a moment and think about how would you implement this data structure in .NET. You can pause the video for a few moments to think about it. So how it is done in .NET? The underlying data structure that is implemented in the Newtons of JSON's base classes is, as you could have guessed, a tree. The tree data structure implements a parent-child hierarchical structure and enables us to travel along it. The most basic class of JSON.NET is the JToken abstract class, seen in the left side of the slide. All the classes we will be working with can be referenced as JToken. It is the common base class for all of them. This class mainly deals with the basic implementations of the tree structure. Functionalities like getting the children of a node, its parent, traversing and enumerating through the nodes, moving to the next or previous node, and so on. Our JToken class from there divides into two sub-successors, the JContainer and the JValue. The JValue class represents an edge or a leaf in the JSON tree, meaning a node that holds an actual value, a string, number, boolean, or null, and have no child J tokens. Note the difference between the implementation and the raw recursive definition on the right, in which value can also be something that holds other sub-values like object or array. In our implementation, this functionality is achieved by polymorphism and the fact that everything derives from JToken. In opposite to JValue, our abstract JContainer class represents a JToken that holds other JTokens in its different driven classes forms. Our JContainer is driven by three classes that contain other JTokens. JObject, which contains JProperties in the form of a dictionary. On the right side, you can see the correspondent element from the JSON definition. A JProperty, which is basically a name JToken pair inside a JObject. And JArray, which contains tokens in the form of an ordered list. After understanding the overall responsibility of each class, let's get a little more familiar with them by further exploring the tools they provide, starting with the JToken abstract class. The JToken class provides most of the functionalities we'll need in basic scenarios. The path property indicates the path of the JToken as a string, where the chain of properties along the tree leading to the JToken are separated by dots. We'll see it in the demo. The type property indicates the JToken type by an enum that can be an array, string, float, and so on. The selectToken method enables us to fetch any child token from the JToken in case we know its path. The valueGeneric method enables us to get the value of the current JToken in the type we specify. Next up are the fromObject and parse method, which enables us to load the JToken from an object or a string. We will usually use these functions to load JSON to memory in case we don't know the exact type of JSON we have in hand, or we just need to do basic operation with our JSON. Our next class is JValue, seen on the right. It inherits JToken and mainly adds the value property of type object. The JContainer abstract class, if you recall from our previous slide, represents a token that holds other JTokens, opposite to the JValue class we just seen that represents a leaf in the JSON tree. The important additions of the JContainer class are the children tokens property, which holds the container's children as JTokens, and two other methods, the add method, which enables us to add JSON object to the container's token, and the merge method that allows us to merge two JSONs together. We will show this method in action and explain it in the demos, so don't worry. And finally, let's talk about the implementing or concrete classes of JContainer. JObject and JArray allows us to comfortably contain other JTokens by also inheriting from iDictionary in the case of JObject, enabling us to hold JProperties in the form of key value pairs, and iList in the case of JArray, enabling us to hold values as an ordered list. These classes also implement the parse and fromObject method like JToken does. So this can be confusing. Which one should we use? We'll come back to this issue in the demos, I promise. Our last class is JProperty, which is much simpler than the other two implementations. It simply holds a string as a name and a JToken as its child value. So, to wrap things up, here on the right side we have a representation of how our gamer's JSON will look like in runtime. On the left are a sample JSON again for reference. We have learned about three types of object that holds other JTokens. The JObject that holds other JTokens in the form of a dictionary, the JArray that holds other JTokens in the form of an ordered list, and JProperty that holds a single JToken. I want to point out some examples from our representation. Our entire JSON will be represented by a JObject containing all of our game's properties as JProperties. The age JProperty on the third line will be set with age as its name and 35 as its JValues value. Our gamer's address JProperty on the fifth line will be set with a JObject as its JValues value. And by the way, if we look at the children tokens property, we will see the two nested properties of our address property. Same goes for our recently played property containing a JArray. We will have a JArray as value and also all the nested properties in the children tokens property. Hello again everyone, and welcome to the demos section of our tutorial. We are in Visual Studio and I've made a little list of topics we're gonna cover. We're gonna go through them one by one. But before that, let's start off by adding the Newtons of JSON library through the NuGet package manager. So let's go ahead and just do that. We're gonna add the latest version. Now that we have added the dependency to our project, let's explore the options it provides for loading our gamer's JSON string to memory. I will quickly write them down. So let's debug our program and discuss the differences between these two options and when to use each one. As we said in the tutorial, the JToken class is the base class for all of Newtonsoft classes, so it provides the most basic functionalities and has the smallest memory signature. It will be perfect for scenarios in which we only need to retrieve data from the JSON or update it, without changing its schema, or we are not sure about the exact type of JSON we have in hand. Is it a JObject, a JArray, and so on. So let's take a look on the JToken object in runtime. As you can see, we have all these properties like last, next, root, which are related to the tree implementation JToken provides. And if we look on the children token property, we will see all of our children properties. Let's take the address property for example. We can see it is of type property and its path is address. If we look at its children, let's take the cities property, for example. We can see it is of type property. Its path is address dot cities. This is the tree path to the property. And if we will look at its value, we can see it is of type array. I noticed I have a little typo here. This is not how you write cities. Sorry about that. So now let's say I want to ask what is the street address of our gamer. How do I do that? Well, I can use the select token method of the JToken object. And use the value method to extract the value as string. And that should give us our street address. Let's rerun this segment. And there we have it, our street address. Another thing we can do is update values. Let's say we want to update the age of our gamer to 36. So we can approach our property as if it was a dictionary. And say we want to update it. Let's rerun that. And now if we will look on our JToken, we can see our age property have been updated to 36. We have seen that we can do most of the basic operation we need by just using the JToken class. So why do we need the JObject class? Well, the first reason is when we want to validate that we have a JObject in our hand and throw in the case of a JArray, for example. And the other reason is when we need to manipulate the structure of our JSON, adding a property or deleting one altogether. Let me show you that real quick. I will use the JObject variable this time. And let's say we want to remove the age property. And let's add a new property to our JObject. We'll call it new property. And let's rerun the segment and see what we've got. So, as you can see, the age property was removed and the new property with the value of 3 was added to our JObject. Another very commonly used feature of JContainer, which JObject inherits from, is JSON merge. Suppose we develop a web server and we want to enable our clients to send a partial update of our JSON without sending all the properties again. How can we achieve that? Well, JSON merge enables us to merge two JSONs together, and I will quickly show that. We are going to update the full name of our gamer. We're going to change it to Bob. And also the balance property. We are going to change it to 200. As you can see, we can provide a merge method with the JSON merge setting object, which enables us to customize the way our merge will work. Things like, how do we treat arrays? Do we merge them? Do we override them? Or null values? Do we ignore nulls or do we merge them? I'm not going to go into details about the JSON merge settings, but you can further read about it in the internet. So, our new JSON contains the updates we setted. We can see the full name is now Bob and the balance is 200. The last thing I want to show is a more complicated query. Suppose we want to fetch all the arrays in our JSON. We can use the descendants method of JObject to get a flattened list of all our J tokens in the JSON, and then use link to query the J tokens and return all the J tokens of type array. So let me quickly write that down. We will have to rerun the program because we don't have a reference to link. And there we have it, all the arrays from our JSON. Okay, so that was our tutorial. Hope you enjoyed it. Thank you for watching.